In this video, we will explain how aminoacyl-tRNA synthetase is capable of achieving high accuracy when charging a tRNA molecule with its correct amino acid. Aminoacyl-tRNA synthetase is an enzyme that catalyzes the charging of a tRNA with its correct amino acid. Remember from lecture how important it is for the correct translation of the genetic code that each tRNA is carrying the amino acid that corresponds to its anticodon site. The charging of tRNA with an amino acid is energetically unfavorable, so this charging is coupled to the hydrolysis of ATP to AMP and pyrophosphate. Let's now see how the enzyme fulfills its challenging task. First, the catalytic site will bind an amino acid. This catalytic site is a first checkpoint as it selects based on size and chemical properties of the amino acid. It excludes amino acids that are larger than the amino acid of interest and only allows smaller or similar sized amino acids. Secondly, it only allows amino acids that have the same chemical properties as the correct amino acid. Chemical properties could be, for example, charge of the amino acid. Once an amino acid is bound to the catalytic site of the enzyme, an ATP molecule will be hydrolyzed to form an aminoacyl AMP molecule, and as a result, a pyrophosphate molecule will be released. In the next step, the tRNA needs to bind to the enzyme. The enzyme recognizes the correct tRNA based on interactions it makes along the surface of the tRNA molecule. Once the correct tRNA molecule is bound, the tRNA will be charged with the aminoacyl molecule present in the active site of the enzyme, and as a result, the AMP molecule is released. A final step we now need to address is correction of mischarging. You can imagine that some of the amino acids are so similar that the tRNA gets charged with the incorrect amino acid. To solve this, those enzymes have an editing pocket. Do note that certainly not all of the enzymes need an editing pocket though. In general, when present, the editing pocket is able to exclude based on size and only allows amino acids that are smaller in size compared to the correct amino acid. Imagine now, for example, that the yellow amino acid that you see here is the wrong amino acid, and it was only able to enter the active site in the first place because it's smaller compared to the blue amino acid of interest. In that case, the mischarged amino acid will be able to enter the editing pocket where it will be removed by hydrolysis. If the amino acid, however, is the correct amino acid, then the correctly charged tRNA will be released from the enzyme and can move to the ribosomes to further assist translation.